questions 11 through 20 on the 2017 Grade 10 AMC 10A. The region consisting of all points in the three-dimensional space within 3 units of the line segment AB has volume 216 pi. What is the length of AB? All right, well, we have to figure this out. What do they mean? And after some thought, it basically is as follows. Let's say you've got this line AB from here to here, this red line. Well, the region that is 3 units away from that line is going to be all the way around. So that's a circle basically all the way around. And as you can see, when it spreads across, it becomes a cylinder. So that's the first part. There's another part to it too. Then sitting on top of each cylinder, and that's going to be harder to draw, is basically a half of a sphere. So sitting on top of each of these cylinders is half of a sphere, like that. I think you have to sort of use your imagination. So we got a cylinder and we got 2 half hemispheres, so we basically have 1 full sphere. And then we have to now figure out the length of AB. So the volume is 216 pi. And that's going to be the sphere, which is, what's the volume of a sphere? 4/3 pi r cubed. Right. And then the volume of the cylinder, which is pi r squared times the height, which in this case is this line segment AB. Yeah. So that is basically what's going to help us solve for AB. Well, the pi's cancel, so that just leaves 216. 4/3, and radius is 3, right? Because it's 3 units away from that line, so this is going to be 3 cubed, and then that's going to be 3 squared, and then AB. So when I solve for this, 216, 9 times 4, 36, plus 9 AB. So 216 minus 36 is 180, is equal to 9 AB, and therefore AB is 180 divided by 9, which is 20. So number 11, the answer is D. Let S be the set of points x, y in the coordinate plane such that 2 of the 3 quantities x plus 2, 3, and y minus 4 are equal, and the third of the 3 quantities is no greater than this common value. Which of the following is the correct description of S? All right, we have 3 scenarios. So let's create those 3 scenarios, and then we will look at the answer choices to see which one matches. So the first one, 3 is equal to x plus 2, and y minus 4 will be less than 3. That's basically from the information in the question. So that means x is equal to 1, and y is less than 7. So if I were to plot this on a graph, it would be x is equal to 1. So let's just say that's x equal to 1, and y is less than 7. So if this is, say, 7 right here, y has got to be less than that. So I'll just draw a circle to represent that point, and then it basically is a ray that goes down. All right, let's do the same thing for the next scenario, which would be x plus 2 is equal to y minus 4. And then the other value, which would be 3, see, x plus 2, or 3 is less than x plus 2. So that means x is greater than 1. And from this guy here, we get that y is equal to x plus 6. All right, same thing. Let's graph this. And we got 6 approximately. We got that 1. And then again, 7, 1 would be approximately here. And that's going to be x is less than that, so it's got to be a circle. And then we're going to draw this. It's going to come down like this, basically. Or actually, sorry, x is greater than 1, so it's going to go that way. All right. Okay, so we got another ray, whatever you want to call it. And then the final one is when we have 3 equal to y minus 4, and then x plus 2 is less than 3. So that means y is equal to 7 and x is less than 1. So graphing this, we get the following. Y is equal to 7, so approximately here. X is less than 1, so here. So this is basically a line. I'll draw the point 17, so it's going to be, again, an empty circle. And then that line, x is less than 1 this time, so it's going to go like this. So there you go. You got 3 rays, and they all seem to have a common endpoint, and that common endpoint is right here, which would be 1, 7. So the answer choices, the one that matches is choice E, 3 rays with a common endpoint right there. Define a sequence recursively by f at 0 is 0, f at 1 is 1, f at n equals the remainder when f at n minus 1 plus f n minus 2 is divided by 3 for all n greater than or equal to 2. Thus the sequence starts 0, 1, 1, 2, 0, 2. What is f 2017 until f 2024? Okay, so obviously we're going to look for a pattern here. So they've given us the first few, 0, 1, 1, 2, 0, 2. And then let's just use that recursive pattern to figure out the remaining numbers in this sequence. So when we do, we get 2, 1, 0, 1, 1, 2, 0, 2, 2, 1, and so on. All I'm doing is just adding those 2 and dividing by 3. So for example, this plus this is 4, divided by 3, remainder is 1. That's why I put a 1 there. And then you take this and this, add them, you get 3, divide by 3, the remainder is 0. That's why I put a 0 there, and so on. So this indeed gives me a pattern, and that pattern is right here. It repeats like that. 0, 1, 1, 2, 0, 2, 2, 1. So that means that it looks like we can figure this out pretty easily. This is f at 8. This one is f at 16. So every 8, it's pretty much the same. So that means if I get up to any multiple of 16, it's going to be this one. Well, 2017, is that a multiple of 6? Is that a multiple of 16? And the answer is no. But one before it, 2016, is obviously a multiple of 16. So that will be 1. And then therefore this guy will be f at 2017. This will be 2018, 2019, and so on. 2020, 2021, 2022, 2023, and finally f at 2024. So this sum right here is really just adding up these numbers. And when you do, you get 9. So number 13, the answer is D. Every week, Roger pays for a movie ticket and a soda out of his allowance. Last week, Roger's allowance was $8. The cost of his movie ticket was 20% of the difference between A and the cost of his soda, while the cost of his soda was 5% of the difference between A and the cost of his movie ticket. To the nearest whole percent, what fraction of A did Roger pay for his movie ticket and soda? All right, let's just give a number, make it easy. Let's say his allowance is $100. Now we got to figure out the ticket price and the soda price. Well, the ticket price is 20%, so 0.2, times his allowance minus the cost of the soda. So that's 0.2 times 100 minus S. So that's going to be 20 minus 0.2 S. Okay. Now we have S, which is the soda, and that is equal to 5%, so 0.05 times his allowance minus the cost of the ticket. So that's going to be 0.05 times 100 minus T. So that's going to be 0.05 times 100. Well, let's substitute in T first. 100, T is minus 20, and then plus 0.2 S. When we subtract it, the signs will change. So this will be 0.05 times 80. So that's 4. And then 0.05 times 0.2 plus 0.01 S. All right, so solving, we get 0.99 S is equal to 4. So S is approximately 4. Just a little over 4, I think, 4.04. And then substituting back into here, we get T is equal to approximately just a little over 19.19, I think. So then we have to figure out T plus S, and that's about 23.2. And compared to A, it's 23% approximately. So number 14, the answer is D. Chloe chooses a real number uniformly at random from the interval 0 to 2017. Independently, Laurent chooses a real number uniformly at random from the interval 0 to 4034. What is the probability that Laurent's number is greater than Chloe's number? Okay. Well, we have 0 to 2017 in this interval. And then we have the other interval is from 0 to 4034. Now, this interval we will break up into two segments, one from 0 to 2017 and the other one from 2018 to 4034. Okay? Now, any number that is chosen in here will be greater than any number here. So 50% of the time, which is a half, we will have a scenario where Laurent's number is greater than Chloe's number. For sure. No matter what the number is, it will always be greater than that. Now we got to concentrate on what happens here. Okay, well, if we choose a number in here, 50% of the time, that number is going to be greater than this number. So L will be greater than C half the time. And C will be greater than L the other half of the time. But there's also one other scenario that C is equal to L. Like, for example, if he chose a number like 212 and this number was also 212. But because these numbers are so big, it's negligible in the total calculations. So we can sort of leave that blank. If the numbers were small, if we're only going from 0 to 6 or something like that, then we definitely would have to keep into consideration this scenario. But these are huge numbers, 4034. So overall, it won't matter so much. So we have to take into consideration that we want a scenario that is like this, where L is greater than C. Well, half of half, because remember, this is half and this is half. So it's really, if we're looking at this, it's a half of this half. I hope that makes sense, which is a quarter overall. So you take this quarter and you add it to this half, and when you do, that is your total probability, which is 3 over 4. So number 15, the answer is C. There are 10 horses named Horse 1 to Horse 10. They get their names from how many minutes it takes them to run one lap around a circular racetrack. Horse K runs one lap in exactly K minutes. At time 0, all the horses are together at the starting point on the track. The horses start running in the same direction, and they keep running around the circular track at their constant speeds. The least time S greater than 0 in minutes, at which all 10 horses will again simultaneously be at the starting point S equals 2520. Let t greater than 0 be the least time in minutes such that at least 5 of the horses are again at the starting point. What is the sum of the digits of t? Well, to get that, they are basically getting the LCM, the least common multiple of all the numbers 1 through 10. And let's write those out. When it's not a prime, let's break it up into its prime factors. 2 times 2 times 2. This is 3 times 3. And this is, of course, 2 times 5. So to get the LCM, the 2, well, we have to put the maximum time it appears, and that would be 3 times. So that takes care of the 2's. 3, again, we have to put it the maximum time it appears, and that would be twice. That takes care of the 3's. 5 only appears once. 7 only appears once. And I think that's it. So 8 times 9 times 5 times 7, and that is indeed 2520. So that's how they got this 2520. So now I have to get the LCM of only 5 of the horse numbers. So because they want 5 of these horses to be coming back to the starting point, and in such a way that it's the least amount of time. Okay, so experimenting with this, let's say if the horses were horses 1, 2, 3, 4, and 5, what will be the LCM? Well, the LCM looks like it would be 2 times 2 times 3 times 5. So that is 4 times 15, 60. Okay. Let's see if I can get a lower LCM. Let's say I use horses 1, 2, 3, 4, and 6. Now let's figure out that LCM. It's going to be 2 times 2 times 3. So that is 12. Well, that is indeed lower. So obviously, this is the one involving these horses. And the sum of the digits of that is 1 plus 2, which is 3. So 3 is the answer to number 16, and that is choice B. Distinct points P, Q, R, S lie on the circle x squared plus y squared is 25 and have integer coordinates. The distance P, Q, and R, S are irrational numbers. What is the greatest possible value of the ratio PQ over RS? Well, let's draw this diagram. This is a circle, obviously, and that circle has this equation. So we'll make it nice and big, and there we go. And the points are integer coordinates, so the only integer coordinates, if you kind of make a little table for x and y, you can just do it on the graph, or you can make the table. It'll be 0 and 5, 1 and 2 won't, but 3 will, 3 and 4, 4 and 3, and then 5 and 0. So as you can see, if I label this graph 5, 0, 3, 4, and it doesn't have to be a masterpiece, just as long as you label it 4, 3, and again back to 0, 5. So those are the only points that would be integers on in that quadrant, and then you keep going all the way around, of course, and you will get very similar. And you label all the points across the circumference of the circle. So now we have to start figuring out this PQ and RS. So if we want this to be the greatest possible, PQ over RS. Obviously, what we have to do is make PQ as big as possible, and RS we have to as small as possible. Well, looking at this, I think the smallest 2 points would be something like this if I were to connect those two. I think that's the smallest distance I can get. So I'll just say this is R and this is S. And I can easily figure out that distance. So it would be 4 minus 3 squared plus minus 3 plus 4 squared, all under the square root, and that's RS. And that's going to be, let's see here, 1 plus 1, so that'll be root 2. Okay, and we got to make sure that it's irrational. Irrational, just if you're not sure what that means, it just means that it cannot be written in the form A over B. And root 2 is an example of an irrational number. So I think that's a pretty good candidate for RS. Now, PQ, we want to make PQ as large as possible. Well, the obvious one is making it straight across, where this is P and this is Q. But if you do that, you get PQ equal to 10. And 10 is not irrational. 10 can obviously be expressed 10 over 1 or 20 over 2. So don't use 10 because that's not irrational. Okay, well, so much for that. How about some other choice? Well, after staring at this for a while, we get to the conclusion that if we chose this as P and then this as Q, or anything really, it doesn't have to match. Say I chose this as P and then this as Q right here. That would give me the largest value of PQ. So let's figure out what that value is using the distance formula. 4 minus 3, so 4 plus 3 squared. And then 3 minus 4, so that's going to be 3 plus 4 squared. And that will give me 7 squared, which is 49, plus 49, and that's root 98. And that's the biggest PQ. So there we go. And again, root 98 is indeed an irrational number. That actually is what, 7 root 2, I think? Yeah, 7 root 2. And root 2 is irrational, so 7 root 2 is irrational. So that's it. So this would be 7 root 2 over root 2, and that is equal to 7. So number 17, the answer is D. Amelia has a coin that lands on heads with probability a third, and Blaine has a coin that lands on heads with the probability of 2 over 5. Amelia and Blaine alternately toss their coins until someone gets a head. The first one to get a head wins. All coin tosses are independent. Amelia goes first. The probability that Amelia wins is P over Q, where P and Q are relatively prime positive integers. What is Q minus P? So if you have Amelia and Blaine, and the probability of heads there is 1/3, so the probability of tails is 2/3. Probability of heads for Blaine, 2 over 5. Probability of tails, therefore, is 3 over 5. Okay, hopefully we don't need to do too many. I have a feeling this is going to be an infinite geometric series just because I've done a lot of these. And the sum of that is A over 1 minus R. But of course, I will explain it. So here we go. And I think I will be okay with just 3 iterations. I think within 3 I should be able to explain it. So, okay, Amelia goes first. We want her to win. So if she gets heads, she wins. Probability of that happening is a third. Game over. Let's say she flips a tail. Well, we want Blaine to flip a tail and then a head for Amelia. So this probability would be 2/3. This is 3 over 5. And this is 1 over 3. So we have to multiply them all. So 2 over 3 times 3 over 5 times 1 over 3. And that would be 2 over 15. And this one was 1/3 if we want to keep them in the same sort of column. All right, let's keep going. Tails doesn't win. Tails doesn't win. Tails again. Tails again, heads. This is a scenario in which Amelia wins. Okay, probability, 2/3, 3/5. 2/3, 3/5. 1/3. All right, so we have to now multiply these guys. 2/3 times 3/5. 2/3 times 3/5. And then 1/3, like that. And this looks like the 3's are going to cancel, so you're going to get 4 over 75. All right. Well, let's see if we get a common ratio. The ratio here is 2/15 over 1/3. And 2/15 over 1/3 is 2/15, invert and multiply, 3/1, and that is 2/5. Okay, let's see if we get that same thing here between these two values, 2/5 and 4/75. 4/75 over 2/15. 4/75, invert and multiply, 15/2. And that looks like 2/5. So indeed the ratio is 2/5. Now you can keep going and do another iteration if you're not convinced, but I think this is sufficient. So now we can figure out the sum. That will represent the total probability that Amelia wins, since this is infinite. A is the first term. That was a third. R is the common ratio. We found that to be 2/5. So 1/3 over 3/5. So invert and multiply, and we get 1/3 times 5/3, and that is 5/9. So 5/9 is my answer, and that it represents the P over Q. And they want me to figure out Q minus P. Well, that would be 9 minus 5, which is 4. So number 18, very good question. The answer is D. Alice refuses to sit next to either Bob or Carla. Derek refuses to sit next to Eric. How many ways are there for the 5 of them to sit in a row of 5 chairs under these conditions? There's a few ways of doing this question, and there's a long way, there's a short way, and I'll do it in a way that I think is relatively short. And of course, that is the method that is preferred on a math contest, since you're limited for time. Okay, so let's say we have Alice. She's in either the first or fifth spot in the row of chairs. So she's here or here. If that's the case, then Eric and Derek have to be next to her because she can't sit next to Bob or Carla. So I've got one choice here that's fixed as Alice, and then 2 choices, either D or E. And then the next one over, we can't put Eric or Derek because they can't sit next to each other. So we've got to put either Bob or Carla. So I got 2 choices there. And then for the last 2, whoever's left, we can put pretty much anybody there. It doesn't matter now. So we've got 2 choices. We have 2 people. If any of those 2 can work. And then, of course, we have one final choice there. So this is 2 times 2 times 2, which is 8. And remember, this is for the first. So for the first, if she's in the first position, there's 8 possible ways of doing it. And if she's in the fifth, it'll be pretty much the same sort of story. So there'll be 16 ways of making it work if she is in the first or fifth position. Now let's put Alice in either the second or fourth position and see what we get. So now she's going to be either here or here. Okay, so let's figure out what we get. If she's in the second spot, the first spot has to be either D or E because she can't be put next to B or C. The third spot, same thing. She can't be sitting next to B or C. So this is fixed as one spot because it's Alice. We can put 2 here, and we could put 2 here. correct? Actually, no. Whoa, that's going to be 1, sorry. Because once you put D here, there's only one guy left. If you put D here, then E has to go there. And now we've got B and C left, Bob and Carla. So B and C can go here. So you got 2 choices. And then, of course, one final choice, whoever's left. So this is actually 4. 2 times 2. And similarly, you can do the same thing for the 4th position, and that would be 4 also. So this gives me 8. Now the third and final is when she is in the middle, the 3rd spot. So if she's in the middle, what is the scenario? Okay, let's figure this out. She goes there. Well, again, because she can't be put next to Bob or Carla, this has to be either D or E. So you got 2 choices there, 1 choice there, and then 1 choice here. If I put D here, I put E here. If I put E there, I put D there, that kind of thing. And then the other 2 guys, obviously, got to be Bob or Carla. So Bob or Carla, 2 choices, and whoever's left goes here, either Bob or Carla. So this looks like 4. And that's it. Now we've got to add these guys, 16 plus 8 plus 4, and that is 28. So number 19, the answer is C. Let S at n equal the sum of the digits of the positive integer n. For example, S at 1507 is 13. For a particular positive integer n, S at n is 1274. Which of the following could be the value of S at n plus 1? Well, this is a pretty large number, so probably is a lot of digits in this n. So what I did is I just said, okay, let's make my life easy here. Let's just say n is a whole bunch of 9s. Whole bunch of 9s just makes it easier to add up. And I want to get this number, 1274. Well, I can't get it with just 9s because 1274 is not divisible by 9. But I can get it with a whole bunch of 9s and a little 5 at the end. 141, if I were to figure out the sum of the digits, 141 times 9 plus 5 is equal to 1274. So this is one example. So now I want S at n plus 1. So the obvious is just to add 1 to this number. So instead of the 5, it would be a 6. And therefore the sum of the digits would be 141 times 9 plus 6, which is 1275. And this is the most obvious one. And as you can clearly see, it's not one of the answer choices, 1275. Okay, so we got to just keep experimenting here. All right. N is not of this form. The 5 is 1 before it. So instead of it being at the very end, it's 1 before it. So it's 9959. This still gives me some of the digits to be 1274. Try it out, you'll see. Where this is now 140, then we got 1 more 9 and 1 5. It'll still be 141 9s plus a 5. Now, if I do n plus 1, that should have been n plus 1, sorry about that. N plus 1, n plus 1. If I do n plus 1, that's going to be ... 9960. Now, the sum of the digits of that would be 140 times 9 plus 6. And that is 1266. Oh, not one of the answer choices. No problem, you just keep going. And I'll spare you the time. I'm sure you could keep going. What you do is you put the 5 a little bit further than what we had. So you put it here, and then you follow it by 4 9s like this. So this is basically 137 9s. This is 4 9s. So again, it's the same, 141 9s. So when you do the sum of the digits, it'll be still 141 times 9 plus 5, which is 1274. But the magic happens now when you do n plus 1. It becomes 9999, whole bunch of 9s, right? but then at the end it becomes 60000. So this is now 137 nines and a 6. So it'll be 137 times 9 plus 6, the sum of the digits. And that is 1239. And that is one of the answer choices for number 20, is D.